Alright guys, I'm going to do a safety meeting first. Well, actually second. So I was looking up a couple of things just to kind of lighten up the mood, and found some funny things here. So you guys might have heard this one before, but I'm going to tell it to you anyway. It's a little joke. So prestigious neurosurgeon calls a plumber to tend to his leaky faucet. The problem requires an easy fix, and the entire job takes less than 2 minutes. Before leaving, the plumber says, "That'll be $200. The surgeon replies, "I'm a surgeon, and even I don't charge $100 a minute." And the plumber says, "Yeah, I didn't either when I was a surgeon. Why do you think I switched?" So, just thought you guys get a little laugh at that. All right. So this one here is on, this training here is on soldering, brazing, safety first, and then there's one after that as well. So I'm going to start on this one here. Hopefully we have enough volume too.
Hi, my name is Mike Hall. I'm here along with Brandon Baxter. We're going to do a short video on soldering and brazing. Let's start out with safety. As always, for those of you who've been on the job and those of you who will be on jobs, PPE or personal protective equipment is a must. Safety glasses and gloves here in our shops, and it will pertain also to the field. So we'll have safety glasses. The gloves will be swapped out for different procedures that we're doing and different things. I'm just wearing some cut-resistant gloves, and as we get to the training, when we start soldering, we'll show you some different things. One thing about brazing and soldering is there is an open flame, so there's a fire potential. Always important to have a fire extinguisher on hand, one that's in working order, full to be checked. So this is what we'll have here. Don't depend on those in the building that you're working. You need to have your own fire extinguisher. Don't just count on one because it's on the wall. So this right here shows full, so we know we're good to go with that. And try to keep it within 25 feet of your working area. Clothing is another thing. Flannel shirts are great. I know it's going to be protecting you from any dripping solder, but there is a fire hazard with them because they do tend to flare up. And if the flame should come in contact with your shirt, you're going to be on fire. And watch frayed clothing is also important. So try to keep away from having clothes that are frayed. Those of you with long hair, it's very important to keep it pulled back or tucked up.
Or long beards.
Long hair.
Protect your hair from flames.
My roots are the only thing that's showing underneath my chin.
Now let's talk about when we ignite a torch. We never want to use a lighter, cigarette lighter, or anything like that. Always try to use a striker. We have one on hand here. This is a cup striker. You can keep your hand away from the flame. If a lighter should be leaking or something like that, you do not have to worry about a fire hazard when igniting your torch with a striker. These strikers come with interchangeable tips, so if you should get into a fix where it doesn't tend to strike, they are interchangeable and come in they're readily available packs, so there's no big deal there. Housekeeping is very important. Again, for your safety, trip hazards, and job cleanliness. Now make sure that your work area is clean before you start and stays clean while you're working. Also, the fire hazard of having flammable materials and stuff on the floor need to be removed and cleaned up away from any work areas. MSDS, Material Safety Data Sheets. They explain or have every chemical and substance that your company is using on that job site. For instance, we have acetylene here, so there's an MSDS on that you have the right to view to see any hazards or anything like that it can produce or do. And that goes along with any other contractor on your job for materials that they're using. They're typically stored, if your job has a job trailer, there should be a copy of yours in the job trailer. The general contractor on the job should have a copy of everyone's that is available to everyone on the job. And if you're working service and you're from job to job a lot, then your foreman most likely has an MSDS on his truck. Always remember that in case you're asked. So from time to time, OSHA hits jobs and they will ask anyone at times, where are your MSDS sheets? So now you know. That's a brief on safety right now, and we'll get into setup. The next step in soldering and brazing is setup. It's always important to think about where you're going to be soldering if you're using stands. You've got walk areas that people are going to be back and forth and you want to avoid. Emergency exits, stairs. Just try to get yourself out of the way, away from combustibles and flammables, again, because you have an open flame. So you wouldn't want a gas can sitting around. That's just some common sense things that we want to put out there for that. Carrying pipes. Now this copper pipe is not very heavy, but it's awkward. Comes in 20-foot lengths. You start walking with a piece in the middle and you've got round corners in a building. You never know who's behind that corner. So it's a good idea. It looks kind of silly. Sometimes you may think it's silly to have two people on a light piece of pipe, but it's for safety reasons, not for the weight. That way somebody can watch around the corner where your eye's ahead of you. And that's always an important thing to do. When you're soldering, soldering's going to drip. It's going to go from a solid kind of will liquefy itself as it heats and it's going to flow. If you're working in buildings where you have finished floors, carpet, you've got to do something to catch that from dripping because it is going to drip. It's inevitable. In this case here, I know our bucket is flammable, but I have filled it slightly full of some water so that it cools it right away, does away with any fire hazard, and keeps the mess up. You can get a box, cardboard box, maybe get some sand. Some will even put down fire blankets. In that case, I do, from time to time, use a fire blanket to protect the carpet, but I just don't like, once I get it folded up and open it back up somewhere else, then I've got all this solder all over the floor again and a mess to clean up. But whatever it takes to protect the floor and your area from solder, because at times too, that solder could also melt into that carpet and you'll never get it out.
All right, any questions on that? Pretty simple stuff, right? MSDSs, do we have MSDSs in our trucks? No? All right, that's something we probably need to get. Just for OSHA, and I don't know if you guys have ever been even, inspected by OSHA, but MSDS is material safety data sheets, and that basically any chemicals we have on the vehicle, that we have on the job site, also that we have here if they were to come to the office. Basically, all of that could be looked up online. It's actually pretty easy, but it's really supposed to be there for you as an employee to know what you're dealing with. So, do you need to wear a respirator? Do you need to wear a mask, gloves, whatever it is? If it's caustic, glues, all the different types of things that we use, we really should get some binders. So I'll look into getting that done. But that's just something that I wanted you guys to kind of to see for the safety part of it. And I like, the one thing I didn't like is him talking about a cardboard box. He mentioned a cardboard box under solder. Obviously that's probably not the smartest thing unless you have sand or something in it, right?
Right.
Okay, so just keep that in mind. And then also, I've the one thing he didn't talk about too much is when you're prior to soldering, what do you have to do prior to soldering? You have to prepare your pipe, right? Mm-hmm. So he was wearing the cut-resistant gloves because there's not only are you sanding, you're reaming, you're doing all of that stuff, right? So those are other things that you need to be careful with so that you're not cutting yourself. I'm not sure if anybody's ever done that before and cut themselves on copper, and it sucks getting that little piece of metal in your thumbs and your fingers, and so just be careful with that. Okay. Let's see if I'm just going to go to the next one here. How many of you guys use acetylene when you solder? Most of you. Some use MAP gas, some use acetylene.
I'm just used to my oxygen torch, so I just use it usually.
I don't think this is the one I wanted to do it, but let's see.
This program will discuss oxyacetylene welding and burning equipment and its safe use. Although it is not possible to cover every possible safety hazard, some of the most common mistakes made when using oxyacetylene equipment will be explained. It really doesn't matter what brand of equipment you use. The dangers are the same. If you have a question about any special equipment or need specific information on the operation of equipment in your plant, check with your supervisor or team leader. The purpose of this program is to develop a better understanding of safety practices required
Looks like
when using
this is
gas
more for-
welding, cutting, and heating equipment.
Or welding and cutting.
If you don't follow the rules,
I don't see
even
it.
a standard regulator can become a killer. For example, a regulator like this one killed a man in Charlotte, North Carolina. It wasn't the regulator's fault. If the man had known and practiced what you will know after viewing this program, he would be alive today. So watch carefully. Your life may depend on it.
Open the valve.
There are
quickly.
10 basic safety rules developed by welding engineers which should be practiced when using oxyacetylene equipment. Rule number 1, blow out the cylinder valves before attaching the regulators to the cylinders. Since many people call a gas cylinder a tank, the two terms will be used interchangeably. Start with the oxygen cylinder. Look at the valve. Inspect it. See if it's got dirt, rust, lubricant, grease, or whatever in it. Some people believe that grease on the threads will help the regulators screw on easier. But the truth is, there should never be any grease or oil anywhere near pure oxygen. And that applies to grease or oil-contaminated gloves or rags, too. While oxygen itself won't burn, it will support combustion. Here's a demonstration that will help you understand. The air we breathe is 22% oxygen. If you light a candle and put a jar over it, it will shortly go out. The reason is the candle uses up the oxygen as it burns until there is only about 16% left, at which point the candle goes out. If you were small enough to get in the jar, you would die because 16% oxygen won't support life. The oxygen in this tank is about 99.5% pure. We'll fill up the jar with it. Now we'll put it over the candle, and you see how much more brightly the candle burns in oxygen. Oxygen doesn't burn, but it sure does support combustion. Oil or grease on the oxygen valve may start a fire when the valve is cracked to blow it out. This can occur without a spark or flame because grease or oil in the presence of oxygen will start spontaneous combustion, which means it will start burning all by itself. So inspect the valve carefully. Now move to a position so that the opening is pointing away from you. Then crack the valve for about a second to blow out any dust, rust, etc., which could cause the regulator to fail to work properly. Check the valve again to be sure it is clear. If it is, mount the oxygen regulator. Rule number 2, release the adjusting screws on the regulators before opening up the cylinder valve. This means you turn the handle counterclockwise to screw it out until there is no pressure on the diaphragm. What this does is to shut off the regulator so that the high pressure which is in the tank can't go into the working mechanism of the regulator or beyond it. Rule number 3, stand to one side of the regulator before opening the cylinder valve. The weakest point of a regulator is the bonnet. If a regulator explodes, it usually is the bonnet that goes first. When it does, the adjusting screw is blown out. If you're right there, it's about the same as standing in front of a discharging .30-06 rifle. Rule number 4, open the cylinder valve slowly. The pressure in a full tank of oxygen is 2,200 pounds per square inch. If you rapidly open the valve, the shock may damage the regulator. So just crack the valve until you see the pressure build up and the needle stop moving. At this point, screw the valve all the way open. The valve on the oxygen has a seat on the top as well as the bottom. This prevents leakage around the valve stem when the valve is all the way open. So make sure you screw it all the way open. Use the same procedure with the acetylene cylinder. First, inspect the cylinder valve. Get in position so that the opening points away from you. Crack crack the cylinder valve for just a second to blow it out. Then install the regulator. Second, be sure the adjusting screw is backed out until there is no pressure on the diaphragm. Third, stand to one side. And fourth, slowly crack the valve until the pressure builds up on the gauge. But there is an important difference. Unlike the oxygen valve that is completely open, the valve on the acetylene tank should only be opened 1/4 to 1/2 turn. In case of a flashback, you don't have time to close a fully open valve, so only open the acetylene valve 1/4 to 1/2 turn. When you've finished mounting the regulators, take time to inspect the hoses for damage or wear and make sure all fittings are tight. Since a loose fitting could let gas escape, check the fitting between the tank and the regulators and the hose and the flash arrestor, and the flash arrestor and the torch. And don't forget to make sure the screw-on tips are secure. Rule number 5, do not use compressed acetylene in a free state at pressures higher than 15 pounds per square inch. Acetylene is a man-made gas, and it's very unstable. According to chemists, acetylene can be handled safely in the pressure range of 0 to 15 pounds per square inch with normal precautions. However, above 15 pounds per square inch, acetylene is likely to explode by itself. 7 pounds per square inch of acetylene pressure is all that is needed to cut 14-inch steel, and most of us don't cut metal that thick. While acetylene is safe up to 15 pounds per square inch, it is a rare situation which requires more than 10 pounds per square inch. If you are operating up in the 15 pounds per square inch range for normal work, you are first of all wasting gas, and second, and most important, you may be putting yourself in a dangerous situation. Rule number 6, purge your oxygen and acetylene gas passages individually before lighting the torch. It really doesn't make any difference which you purge first, but it is a good practice to have a routine. We'll start by purging the oxygen first. Check to see that the acetylene valve on the torch is closed. Open the oxygen valve and adjust the regulator to the correct operating pressure setting while the oxygen is flowing. Shut the oxygen valve off and repeat the procedure for the acetylene. This routine does two things. First, you get rid of any foreign gas that may be in either of the regulators, and second, you set your regulator pressure while the gas is actually flowing. Rule number 7, light the acetylene before opening the oxygen valve on the torch. Most operators don't like to light the acetylene first because of the slight amount of black soot created. However, this is the correct way. It is important to form the habit of lighting the acetylene first and then opening up enough oxygen to get a neutral flame. Always use a friction lighter because you are likely to burn yourself trying to light the torch with a match or other lighter. Open the acetylene valve until the flame stands away from the tip before it starts to flare out. This will reduce the black smoke to a minimum. If you don't open the acetylene valve this much, you will get more smoke and it will be burning inside the tip, which could result in a flashback. Next, open the oxygen valve on the torch and adjust it for a neutral flame. A neutral flame is one where there is neither excess of oxygen nor acetylene. When this is true, there will be a little inner flame surrounded by a barely visible envelope of flame. Meet Harry, a maintenance man with 20 years of experience. Harry considers himself an expert with this equipment, but Harry has a problem. He doesn't realize the importance of rule number 7. Harry has been working several hours when lunchtime rolls around. So he turns off the valves, lays the torch down, and goes out to the lunchroom to eat. While Harry is at lunch, George needs to use the equipment. George is a maintenance man, just like Harry, with about 15 years experience. George doesn't use the equipment as much as Harry, but he does recognize that he will need a cutting head on the torch. So he takes the torch apart and installs the cutting head. He lights the torch, but when he tries to cut, he finds out right away that he doesn't have enough oxygen pressure to do the job. He has a pretty good heating flame, but it won't cut a thing, so he shuts it down. Like Harry, George likes to take shortcuts too. He never uses a chart to determine what the proper oxygen pressure should be for a certain size tip. He just goes over to the regulator and cranks it down until it reads about 50. He mashes on the torch lever and hears the oxygen whistle and figures it's about right. George lights the torch and does his job. When he's finished, George replaces the cutting head and leaves the equipment like he found it. When he returns from lunch, Harry doesn't look at his gauges. He uses his standard shortcut. Since he doesn't like the black smoke you get when you light the acetylene first, Harry always cracks the oxygen valve on the torch before lighting the acetylene. Let's replay that action, except this time, keep an eye on the acetylene gauge. Notice what happens when Harry opens the oxygen valve on the torch. The pressure rises, which means that the 50 pounds pressure of oxygen, even though it was flowing out of the tip, overcame the 5 pounds per square inch acetylene pressure in the mixing chamber and caused a reverse flow in the acetylene line. If the check valves hold, Harry would be okay. But if the check valve on the acetylene hose leaks or is stuck open, there would be a mixture of oxygen and acetylene in the acetylene line and in the diaphragm area of the regulator. If Harry lit the torch, since an oxyacetylene mixture flashes back at approximately 24 feet per second, in about 2 seconds, this regulator would blow up. If Harry had remembered rule number 7 and lit the acetylene first and then opened the oxygen valve until he had a neutral flame, the oxygen valve on the torch would have reduced the pressure enough to keep oxygen from flowing back into the acetylene and thus would have prevented an explosion. Here we have 3 balloons. The green one is filled with oxygen, the yellow one with acetylene, and the red one with a mixture of the two. When the flame of a torch touches the green balloon, the oxygen helps the rubber to burn quickly, but oxygen doesn't burn by itself. The acetylene burns with a puff. Since the 22% oxygen in the air isn't enough to burn all the acetylene, part is converted to carbon, which made the puff of smoke. Finally, the red balloon. Because of the limitations of the sound equipment, this may not sound like much of an explosion to you, but it will make your ears ring for 10 minutes. Remember that a regulator would hold several times this much because the gas is under pressure. You see what just a little of the mixture of oxygen and acetylene can do, so don't take chances. Rule number 8, never use oil on regulators, torches, fittings, or other equipment in contact with oxygen. Oil in contact with oxygen can burst into flames with no spark at all, so never put oil or grease anywhere on gas welding equipment. If you put your welding regulators or torches into a toolbox, be sure that there aren't greasy fittings or greasy rags in there. If you should get some oil or grease in a regulator, don't try to clean it yourself. Send it back to your supplier for service. Don't weld or handle gas welding equipment with greasy hands. A greasy hand in a blast of oxygen can make a gruesome torch. Rule number 9, do not use oxygen as a substitute for air. Some old timers may say, get me a tank of air, when they really mean, get me a tank of oxygen. While they know what they mean, a new helper may not understand and may think it is actually air in the tank. If oxygen were used for spraying paint, for example, there would be a danger of fire or explosion. So get in the habit of calling oxygen, oxygen, not air. Always look at the name of the gas that is in the cylinder. It is always printed right near the valve. Don't trust the color of the bottle. Rule number 10, keep your work area clean of anything that will burn. When you have your glasses on, a spark could start a fire behind you and might get out of control before you noticed what was happening. Sparks have been known to travel as much as 35 feet from the work area during the burning process. Make sure you have the proper fire extinguisher nearby. That covers the 10 main rules, but there are a few more we need to briefly mention. One of the most obvious is always wear eye protection. You could actually do gas welding or cutting without special glasses, but if you did, you will probably be blind from splatter or spark getting in your eye, or suffer permanent damage from infrared or ultraviolet radiation. Compressed gas cylinders should only be stored in designated areas that are dry, well ventilated, and protected. Cylinders should be upright, have their protective caps in place, and be securely fastened. Fuel gas and oxygen should not be stored side by side. When moving or transporting cylinders, check to make sure that the valve protection cap is in place. Never use the cap to pick up a cylinder. Cylinder hand trucks are the preferred way of transporting compressed gas cylinders. A proper cylinder hand truck, chains, steadying device, or other special carrier should also be used to keep cylinders from being knocked over while in use. Make sure the cylinder is secured before the protective cap is removed. Never use a regulator designed for one type of gas on a different type of gas. Never try to use gas from a cylinder without a regulator. Always close the valve on empty cylinders. This prevents dirt and moisture from entering the tank. A cylinder holding a compressed gas should never be subjected to a temperature more than 125 degrees Fahrenheit. Now let's take a closer look at that fatal accident that occurred in Charlotte, North Carolina, when a man failed to follow the rules. The man was out on a job doing some cutting. A normal gauge setting for this job would be 5 pounds on the acetylene gauge and 40 on the oxygen gauge. After a while, he ran out of oxygen. As soon as he realized what was happening, he cut off the acetylene at the torch. But note, this is mistake number 1. He didn't cut off the oxygen valve on the torch. Next, he went over and took the regulator off the oxygen tank, but he made mistake number 2. He didn't screw out on the regulator adjustment to shut the regulator off. If he thought about it at all, he may have thought it was already set, so why mess with it? Anyway, he just took the regulator off the tank and laid it down. After he got another cylinder of oxygen, he put the regulator on the new tank, but still without shutting the regulator off. Before resuming the job, he took a break and didn't open the valve on the oxygen tank. When he came back, he forgot he hadn't turned the oxygen on, so he went over to his torch and made mistake number 3. He didn't purge the line. If he had, he would have realized that he didn't have any oxygen pressure, and that he had forgotten to close the oxygen valve on his torch. Instead, he turned the acetylene on and lit it, but couldn't get a neutral flame because he had no oxygen pressure. At this point, he realized he had forgotten to open the valve on the oxygen tank, so he shut off the oxygen and acetylene valve on the torch. Let's look at what happened up to this point. When the acetylene valve on the torch was opened, acetylene went into the mixing chamber, and part of it went out the tip to be burned. Since the acetylene had 5 pounds per square inch and there was no oxygen pressure, acetylene backed up on the oxygen side. Since the oxygen valve on the torch was open, it went right on back to the check valve. What the man had no way of knowing was that a bit of grit had gotten into the system and the check valve was stuck open. So the acetylene went right on past the check valve and into the hose and back to and through the oxygen regulator. Remember, he hadn't shut off the regulator. After lighting the torch, he realized he had no oxygen pressure, so he cut off the oxygen valve at the torch. At this point, he literally created a bomb. Acetylene is all the way back to the valve on the oxygen cylinder and is now trapped there. So he made his 4th mistake. He went over and stood in front of the regulator. And then he made his 5th and last mistake. He quickly opened up the valve on the oxygen cylinder. The 2,200 pounds per square inch pressure in the oxygen cylinder slammed toward the regulator and started compressing the acetylene. When the acetylene got to some point above 32 pounds per square inch, it exploded. The explosion burned the man rather badly, but that didn't really make any difference because the adjusting screw on the regulator had already killed him. Remember, he was standing in front of it. You should remember the rules. It's your life we're talking about. Follow the rules. Here they are again. Number 1, blow out the valve on the cylinder, but point it away from yourself. Number 2, release the adjusting screw on the regulator before opening the valve on the cylinder. If you back out this screw, which closes off the regulator, you will greatly reduce your chances of having an explosion. Number 3, when you make that adjustment to the regulator, stand to one side. If that regulator should blow, it would be bad enough to get a burned hand, but it sure would be better than getting killed. Number 4, open the cylinder valve slowly. After making all the other mistakes, the man who was killed might not have had an explosion if he had opened the oxygen slowly. Number 5, do not use or compress acetylene gas in a free state to pressures more than 15 pounds per square inch. It becomes unstable above that pressure. Number 6, purge your oxygen and acetylene lines individually before lighting the torch. This cleans out any mixture which may be in the hose or regulator. Number 7, always light the acetylene before opening the oxygen valve. A little soot is nothing compared to an explosion. Number 8, never use oil or grease on regulators, torches, fittings, or other equipment in contact with oxygen. Be careful where you lay that regulator when you take it off the cylinder. Number 9, never use oxygen as a substitute for compressed air. Number 10, keep heat, flame, and sparks away from combustibles. If you will follow these rules, you will greatly reduce the chances of an accident. If there is a question, check with your supervisor or team leader, because special equipment frequently requires special precautions.
What'd you guys think of that? Learn anything?
That was a good one.
I don't know.
So-
That was a good refresher from my AWS certification.
I don't know a lot of that, some of that stuff.
So, I mean, a lot of people who, in the plumbing industry, who come in and start using acetylene for, doesn't matter if you're brazing or if you're, I mean, we don't do any real cutting, most of us don't anyway, but they get taught by somebody else who doesn't necessarily, hasn't gone through any training. And they don't know these little things. And those little things, they light it how they want to light it. They don't necessarily pay attention to all those little things. So I just thought this would be a good thing for everyone to kind of get a little training on. And, the last thing you want to do is get hurt with this. Because this is one of the things, when it comes to using acetylene torches or any kind of torch, but acetylene in particular, you're having, there's a much bigger chance of getting hurt if you don't know how to work it. So.
One
that
thing
was-
I can say about the acetylene real quick that was not discussed in either video.
What's that?
Do not, under any circumstance, lay that cylinder down flat. That cylinder is filled with like a foam porous material. That gas is only stable because it's in acetone. When you lay it down on its side and you stand it up to go use it, it takes a couple hours for all of that to go back down to the bottom of that tank. You pull it through your regulators, you just bought yourself a set of regulators. Or worse, same thing like they said, it explodes. And so, I mean, you can store them if it's your backup tank, but no, since it's been horizontal, you can't use that tank anymore for at least a couple hours.
All right, good. So don't put it down. It's a good thing to know as well. Don't lay it down.
And,
Keep it up.
I mean, it's up to you guys, but I was always taught never open cylinders all the way, especially your fuel cylinder. You crack it about a quarter turn and that's it.
He said on here the oxygen you want to open all the way, but you don't want to on the acetylene.
Yeah, and I think
I
that's
was worried
'cause-
about leaks out the bonnet,
Right.
the
Yeah.
shut-off valve, and that would stop that.
Yeah,
So,
and
yeah.
they're talking about B tanks, so they're talking much
Yeah.
larger tanks that you're gonna probably leave them on for storage. It's always good practice when you're done with your torches, turn your shut-off valves off, because I don't know if anyone's been there where you run out of oxygen because someone
Those
didn't
gases
shut
will
off.
leak, and they'll
Yeah.
leak into your truck when the door's closed.
Yeah.
And,
Making a nice
that's not
little.
good.
Yeah, let's not do that.
All right. So all right. That's a hopefully that's a good lesson for especially the people who haven't seen that. Anybody's going to watch the video. The only other thing I really had to talk about, other than the safety and the little joke that Kevin missed, but I'm going to tell you another one. So 'cause I saw one on here that was kind of funny. I put a good chunk of money down to bet that you'll never find a plumber who bites their nails. So that was, I thought that was kind of a little funny. Not as funny as the first one, but being and I'm going to just say this to everybody here as far as being on time and trying to be on time to these meetings. I understand we have traffic coming from LA, I'm coming from San Diego, so I get it. You're going to be a little late. You need to be making sure that I get texted. What's been happening lately is someone's going to be late and they're letting somebody else know. And then I'm finding out from, if it's Omar, whomever it is, I need to know. Same thing if you're going to be sick, make sure I'm aware of it. And, we need to stop this. Everyone's coming in half hour late. Make sure you guys give yourself plenty of time to get here. I know things are going to happen, but I've been going back through my texts on certain individuals, and I'm seeing a huge pattern. And it's just getting to the point, where we are trying to make sure we get jobs done and get things going, and it slows everything down. We have to switch things up to get things done because Kevin's gets up in the morning and is looking at the board and trying to see who's going to go where, and then all of a sudden someone doesn't show up or someone's sick and you know, we're not really knowing about it right away. So please make sure that you're communicating and being on time. That way we can all run our business and make money and do what we need to do, okay? You got anything, Kevin?
Nope.
All right, that's it, guys.